हमने चैप्टर स्टार्ट किया है स्ट्रक्चर ऑफ एटम। इसमें बोर्स मॉडल फॉर हाइड्रोजन एटम पे हम लोग लास्ट 5 इयर्स में जो भी क्वेश्चन पूछे उसको सॉल्व करेंगे। आपको फॉर्मूलेज दिए हैं मैंने स्क्रीन पे, पहले आप नोटबुक में ये नोट कर लो, फिर हम स्टार्ट करेंगे क्वेश्चन सॉल्व। यहाँ पे आपको दिया है एनर्जी ऑफ क्वांटम रेडिएशन का फॉर्मूला, देन वेव नंबर ऑफ सीरीज ऑफ हाइड्रोजन स्पेक्ट्रम। ये फॉर्मूला बहुत इंपॉर्टेंट है, ये बहुत क्वेश्चंस में पूछा गया है, तो आप इसको अच्छे से लर्न करो। यहाँ पे आपको दिया है बोर्स फ्रीक्वेंसी रूल, देन एनर्जी ऑफ एन इलेक्ट्रॉन इन द nth ऑर्बिट ऑफ हाइड्रोजन लाइक स्पेक्ट्रम्स। देन यहाँ पे कौन सा वेरिएशन हो सकता है वो पूछ सकते हैं आपको, सेकेंड ऑर्बिट का एनर्जी निकालो, थर्ड ऑर्बिट का। अकॉर्डिंगली यू हैव टू पुट द वैल्यूज ऑफ n एंड एटॉमिक नंबर z, देन यू कैन कैलकुलेट द एनर्जी ऑफ एन इलेक्ट्रॉन। फिर आपको पूछा है यहाँ पे रेडियस ऑफ बोर्स ऑर्बिट, how to calculate it, then energy difference for an electron transmission in hydrogen atoms। ये भी फॉर्मूला बहुत इंपॉर्टेंट है, सब आप नोट करो, फिर हम स्टार्ट करेंगे क्वेश्चन सॉल्व। यहाँ पे डी ब्रोगलीज इक्वेशन पूछा गया है, आप अगर डायरेक्टली ये लास्ट वाला फॉर्मूला भी लर्न करोगे तो भी सफिशिएंट है, नो नीड टू लर्न हाउ इट गेट डिराइव्ड। आप डायरेक्टली ये लर्न करो, इसी पे डायरेक्ट क्वेश्चन पूछा गया है। देन मैक्सिमम नंबर ऑफ इलेक्ट्रॉन्स इन ईच प्रिंसिपल शेल, then है maximum number of electron in the subshell, that is principal quantum number, azimuthal quantum number, on that questions are there. First question is that the value of Rydberg constant in joule, value of Rydberg constant पूछा है but in joules, इसका मीटर एंड सेंटीमीटर में वैल्यू वेरी हो सकता है, but in the joules if we take its value is 2.18 into 10 raised to minus 18. Option number A is the correct for this. Question number 2. What is the energy of an electron in its ground state? Ground state means always n is equal to 1. इलेक्ट्रॉन कभी भी न्यूक्लियस में नहीं जाता है, कौन से भी इलेक्ट्रॉन का ग्राउंड स्टेट है तो n is equal to 1 वैल्यू फर्स्ट ऑर्बिट वी हैव टू कंसीडर। तो हम यहाँ पे कंसीडर करेंगे कि हाइड्रोजन एटम है जो कि उसका जो भी इलेक्ट्रॉन है वो फर्स्ट ऑर्बिट में आता है, उसका ग्राउंड स्टेट n is equal to 1 है। Then by putting the values of in the formulas for calculating the energy of electron, its formula is En is equal to minus 2.18 into 10 raised to minus 18 z square by n square. Here z is the atomic number we have to consider and n is the orbit number. If we put the values, we get the answer minus 2.18 into 10 raised to minus 18 joules. If we see the options, then option number C is the correct for this. Question number 3 is what is the radius of Bohr's first stationary state? For calculating the radius, it have the formula Rn is equal to 52.9 into n square divided by z. Here z is the atomic number, n is the orbit number. Then if we keep the values, then we get the answer 52.9. Your correct option is A option. Question number 4 is what is the energy of an electron in stationary state corresponding to n is equal to 2? इस तरह का सवाल हमने सॉल्व किया है जब जहाँ पे पूछा था हमें इलेक्ट्रॉन अगर ग्राउंड स्टेट में है तो उसका एनर्जी क्या है। यहाँ पे हमें पूछा है अगर इलेक्ट्रॉन n इज इक्वल टू 2 सेकेंड ऑर्बिट में है तो उसकी एनर्जी क्या है। तो यहाँ पे हम अगेन हाइड्रोजन एलिमेंट कंसिडर करेंगे, एटॉमिक नंबर 1, तो उसके लिए एनर्जी कैलकुलेट करेंगे। ई एन इज इक्वल टू माइनस 2.18 इंटू 10 रेज टू माइनस 18 जेड स्क्वेयर बाय एन स्क्वेयर जूल्स, ये फॉर्मूला है इसके लिए। देन बाय पुटिंग द वैल्यूज जेड इज इक्वल टू 1 एंड एन इज इक्वल टू 2 वी गेट द आंसर माइनस 0.545 इंटू 10 रेज टू माइनस 18 जूल्स। एंड इसके लिए करेक्ट ऑप्शन है हमारे पास ऑप्शन नंबर बी। क्वेश्चन नंबर 6 है व्हाट इज द करेक्ट मैथमेटिकल एक्सप्रेशन ऑफ हेसेनबर्ग्स अनसर्टेनिटी प्रिंसिपल। इसके लिए ऑप्शन नंबर कौन सा करेक्ट है? सी। नो नीड टू डिराइव दिस हाउ इट गेट कैलकुलेटेड, डायरेक्टली आपको ये लास्ट वाला फॉर्मूला याद करना है। And if we see this and see the options, then C option is the correct for this. Question number 7. What is the relation between radius, order of orbit and nuclear charge of hydrogen like species? इसके लिए डायरेक्ट फार्मूला पूछा गया है आपको रेडियस ऑफ बोर्स ऑर्बिट का, जो कि फार्मूला है 52.9 इंटू एन स्क्वायर बाई जेड। अगर हम ऑप्शंस ऑब्जर्व करेंगे तो इंस्टेड ऑफ 52.9 दे केप्ट हियर ए नॉट, और ये ऑप्शन नंबर सी इज करेक्ट फॉर दिस। क्वेश्चन नंबर 8 है व्हाट इज द एनर्जी एसोसिएटेड विथ फर्स्ट ऑर्बिट ऑफ लिथियम +2। यहाँ पे लिथियम भी पूछा है और ऑर्बिट का उसमें 2 चार्ज है। देन अकॉर्डिंग टू दिस formula is that En is equal to minus 2.18 into 10 raised to minus 18 z square by n square. Here we will put the value of z is equal to 3 and n is equal to 1. By putting the values we will calculate and our answer is minus 19.62 into 10 raised to minus 18 joules. Option number B is the correct option for this. Question number 9. Which of the following is not hydrogen-like species? Here He is the correct answer because its outermost orbit is fulfilled. It is the most stable element. Question number 10 is calculate the radius of first orbit of beryllium plus 3 charges there. Again here आपको radius calculate करने के लिए पूछा है। Rn is equal to 52.9 इंटू एन स्क्वायर बाई जेड, ये फॉर्मूला है उसके लिए। z की वैल्यू z इज इक्वल टू 4 रखेंगे, n की वैल्यू n इज इक्वल टू 1। बाय पुटिंग ऑल दिस वैल्यू वी गेट द आंसर 13.23। योर ऑप्शन नंबर डी इज करेक्ट फॉर दिस। क्वेश्चन नंबर 11. व्हाट विल बी द वेवलेंथ ऑफ अ बॉल ऑफ मास 0.1 kg मूविंग विथ वेलोसिटी ऑफ 10 मीटर पर सेकेंड? Here for this formula is lambda is equal to h by mv, where h is the Planck's constant, m is the mass, v is the velocity. We will put all these values. It is already given. All values. H Planck's constant also provided. By putting these all values, we get the answer 6.6 into 10 raised to minus 34 meters. According to the answer, option number C is correct for this. अब सॉल्व करेंगे क्वेश्चन नंबर 12. व्हाट इज द एंगुलर मोमेंटम ऑफ एन इलेक्ट्रॉन इन फोर्थ ऑर्बिट ऑफ हाइड्रोजन एटम? हियर क्वेश्चन इज आस्क्ड अबाउट द एंगुलर मोमेंटम, देन यू शुड नो द फॉर्मूला. एंगुलर मोमेंटम mvr is equal to nh divided by 2 pi. Then angular momentum, by putting the values, what we will get angular momentum of an electron in fourth orbit of the hydrogen atom. N is equal to 4 we have to write here. We have to take the value of n is 4 because angular momentum of fourth orbital only asked. That's why we will put here n is equal to 4. Then our formula becomes by putting the value 4h divided by 2 pi. Then we will cut by 4 by 2. Then it remains 2h by pi. And your correct option will be C option, 2h upon pi. Question number 13 है which of the following statement is not true about Bohr's atomic theory? In that first option is an electron in hydrogen atom can move around the nucleus in one of the many possible orbits of fixed radius and energy. It is the correct one. B option is the energy of an electron in the orbit does not change with time. This sentence also correct, but our question is that not true, we have to find out. Then let's check the option number C. An electron can move only in those orbits for which angular momentum is integral multiple of h by 2 pi. That is also true. And last one option is D. This model can explain the ability of atom to form molecules by chemical bonds. In Bohr's atomic model, if you have learned it carefully, then we saw that about the chemical bonding, it is not explained anything there. That's why for this question, option number D is the correct option. Question number 14 is that calculate the radius of second orbit of helium atom. Then already you know the formula, radius of nth orbit, then Rn is equal to 52.9 into n raised to 2 by z. This is the formula. When we keep z is equal to 2 and what we have to keep n is equal to 2. Then after putting these values we get the answer 105.8. That is your option number C is correct. Question number 15 is calculate radius of third orbit of helium atom. Here in the previous question second orbit asked, now in this question about the third orbit asked, only we have to change the value of n. Remaining all things will be the same, as the formula is Rn is equal to 52.9 into n square by z. Z is equal to 2 and n is equal to 3 we will keep. Then by calculating we get the answer 238.1, and from the option if we check, option number C is the correct one. Then question number 16 is what is the radius of fourth orbit of beryllium plus 3. This is also the same question, only n is equal to 4. I think you have already now got the formula what to use. Here we will put z is equal to 4 and n is equal to 4. Then we will get the answer 211.6. That is your option number A is the correct one. Question number 17. Calculate the radius of third orbit of the hydrogen atom. If we see these questions carefully, same question, same formula using questions are asked repeatedly. If you check the years 2023 this year also it is asked. Then same formula Rn is equal to 52.9 into n square divided by z. Then we will put z is equal to 1 and what is the value of n? N is equal to 3 because third orbit asked radius of third orbit. Then by putting the values what we will get? We will get the answer 216.6. Then if we check the options, then option number D is the correct option for this. Question number 18 is that what is the radius of the fourth orbit of hydrogen atom? I think you can try it. Just pause the video and you can try this. If you are not able, then you can see the solution. Here is the solution. For the calculation of radius, we use the formula Rn is equal to 52.9 into n raised to 2 by z. Here z is equal to 1 and n is equal to also n is equal to 4 we have to keep. Then we will get 846.4. Then if we check the options, option number A is the correct option for this. Question number 19 is find the radius of fourth orbit of hydrogen atom if its radius of first orbit is rpm. Then we have to calculate here radius of the fourth orbit. If we compare radius of first orbit and radius of the fourth orbit, we can get the value easily. Then here radius of the nth orbit formula is Rn is equal to n square by a naught. Here we will take, we are not considering the n because n in both cases is equal to 1. And again which information is provided, where a naught is the radius of the first orbit and which we supposed to write rpm. Here what is pm? Just one thing for you. Pm is the unit for measuring the radius of orbit. Pm means picometer, which value have 1 pm is equal to 1 into 10 raised to minus 12 meters. Then for this question we get radius of the fourth orbit of hydrogen. R4 is equal to 4 raised to power 2 rpm. It is 16 r. Then here if we go by the options, then option number D is the correct for this. Question number 20. Which expression from following is commonly known as Bohr's frequency rule? Indirectly here they asked about the formula of Bohr's frequency rule. That is V is equal to delta E upon H. And again how we can write delta E? It is the change in energies. E2 minus E1 by H. Then option number C is the correct option for this. Question number 21. Calculate the energy associated with the second orbit of helium plus. Here we have the formula. Energy of nth orbit En is equal to minus 2.18 into 10 raised to minus 18 z square by n square. Here we will put the values. Z is equal to 2 and n is equal to also 2 because energy associated with the second orbit is asked. That's why both values will become equal. Then our final answer will become minus 2 into minus 2.18 into 10 raised to minus 18 joules. And if we check the options, option number A is correct for this. Question number 22. Which emission transition series is obtained when electron jumps from infinite orbit to first orbit? Then this series is the Lyman series, because whenever the electron is in infinite orbit and it jumps its basic orbit, or we can say its ground orbit, it is the n is equal to 1, and this series is Lyman series only. Observe this series carefully. Lyman series, Balmer series, Paschen series, bracket series and Fund series. If electron is jumping from infinite orbit to first orbit, it is Lyman series. You have to check here which one is the basic orbit of the series. Lyman series basic orbit, ground orbit, if we can say, it is n is equal to 1. In Balmer series it is n is equal to 2. Then Paschen series n is equal to 3, bracket series n is equal to 4 and Fund series n is equal to 5. No one electron from infinity to go in first orbit in the Fund series or bracket series, any other series. It is true for only Lyman series. Accordingly, you have to write the answers. Question number 23 is same asked. What is the value of N1 for the Balmer series according to the emission spectrum of hydrogen? Now I have shown you in the previous slide only what are the types of series. In that you can check again. For the Balmer series, its emission spectrum of hydrogen is 2. N is equal to 2 only. That's why here option number B is correct for this. Question number 24. What is the wave number of proton emitted during transmission from orbit n is equal to 3 to n is equal to 1? And in hydrogen atom. Then the Rydberg constant value is given, and by putting the values and we will calculate this. Here is the calculation. What is the formula for that? V is equal to 109,677 is equal to 1 divided by nf square minus that nf means that is the final orbit, that's value is 1, and if we take the initial value of the orbit it is 3. Then if you check it carefully, its values of final orbit and initial orbits are different one. Whatever given, that we have to put that only. We cannot put bigger number first and small number afterward. That according to the given question, according to the information given in the question, we have to use that. Then by putting the values, as we take the cross multiplication of 1 by 1 minus 1 by 9, we get the 8 by 9. After that final answer 97,612.53 centimeters, we will get the answer. Question number 25. Calculate the shortest wave number in hydrogen spectrum of the Lymer series. Here Lymer series corresponds to the transmission of n is equal to 2 to n is equal to 1. Therefore, n2 is equal to 2. Here we will calculate this in next slide. Here again same formula we have to use. V is equal to RH. RH is the Rydberg constant. That value is already provided in the question. And N2 is equal to 2 we have to take. Then by putting the values we get, if we take the cross multiplication, 1 minus 1 by 4, we get 3 by 4, and final answer is 82,257.8. This is the answer. Question number 26. Calculate the wave number of photon emitted during the transmission from the orbit of n is equal to 2 to n is equal to 1 in hydrogen atom. Then again the same formula. V means what? Wave number we are calculating here. Wave number is equal to Rydberg constant into 1 upon nf square minus 1 upon ni square. Here nf means final orbit and ni means initial orbit. Here ni is equal to 2 we have to take, and nf is equal to 1. Then by putting the values we get, if we put the values and take the cross multiplication, again we got 3 by 4, and your final answer is 82,257.8. That is your option number D is the correct for this. Question number 27. What is the wave number of photon emitted during transmission from orbit n is equal to 4 to n is equal to 2 in hydrogen atoms? Here again Rydberg constant value is provided. I think now you have learned the formula for wave number. Then use that, and if we keep the values, then we get after cross multiplication 12 upon 64, and your final answer is 20,564.44, and your option number A is correct for this. Question number 28. Calculate the wavelength of photon emitted during transmission from the orbit of n is equal to 3 to n is equal to 2 in hydrogen atom. Now you know the formula of wave number. Use it. Here you have to use Ni is equal to 3 and Nf is equal to 2. By using these values you can try this question, and if you are not able, then you can see this solution. Then after putting the values we get 15,232.9. That is option number A is the correct for this. Question number 29. Which of the following equation represents dual behavior of matter according to the de Broglie's? Here indirectly they asked the de Broglie's equation only. Then you know the formula, lambda is equal to h upon mv. This is the correct option, option number C. Question number 30. Which from following is correct relationship between wavelength and the momentum of electron? Here we know de Broglie's equation, lambda is equal to h upon mv. Instead of mv, what we can write? That is mv is nothing but the momentum p. That's why here formula will become lambda is equal to h upon p. Then your correct option will be first option, option number A. Question number 31. Which of the following equation represents Heisenberg's uncertainty principle? We have solved this question previous also, in previous year also this is asked, and in year 2023 also it is asked. Here Heisenberg's uncertainty principles formula asked. Which one is? Option number A is correct for this. Delta x into delta px is greater than greater than or equal to h upon 4 pi. Question number 32. Which of the following equations gives angular momentum of an electron in a stationary orbit? Can you see this question is asked in 2024, 2023 and 2021 also. Repeatedly this question is asked. Only you have to remember here formula for the angular momentum. mvr is equal to n into h upon 2 pi, which is B option is correct for this. Question number 33. What is the radius of first orbit of monopositive helium atom? Here we know the formula for radius of nth orbit. Rn is equal to 52.9 into n raised to 2 by z. Here we will take z is equal to 2 and n is equal to 1. By putting the values in the formula, we get after the calculation 26.45 pm. That is pm means picometer. Question number 34. Energy of an electron of hydrogen atom in ground state is minus 2.18 into 10 raised to minus 18 joule. What is its value in stationary state for n is equal to 2? Here for the energy of electron for that formula is E2 is equal to minus 2.18 into 10 raised to minus 18 z square upon n square. Here n is equal to 2 we will take and z is equal to 1. By keeping the values after calculation we get minus 5.45 into 10 raised to minus 19. That your option number D is correct for this. Question number 35. We have solved this question also before this. In previous year, this question, same question is asked. Which of the following statement is not true about the Bohr's atomic model? And in that also we got the answer. Option number D is not true for this. About the chemical bonding, Bohr's model not saying anything. Question number 36. What is the momentum of a microscopic particle having the Brownlee's wavelength 7.2 Armstrong? Here Planck's constant H also provided. Then according to the formula lambda is equal to H upon P. Then for if we convert this formula for the P, then we get P is equal to H upon lambda. Then by putting the values we get answer 9.2 into 10 raised to minus 25. Then here your option number C is correct for this. Question number 37. What is the wave number for transition of photon from orbit of n is equal to 5 to n is equal to 2? Here Rydberg's constant also given, and as you know the formula for wave number V is equal to Rydberg's constant into bracket 1 upon nf square minus 1 upon ni square. Use that formula. Try to calculate. You can send your calculation to me in the chat box also, in the comment box also. And if you are not able, then you can see this. This is the solution for this. Put the values and then after that cross multiplication of 1 by 4 minus 1 by 25 we get 21 upon 100 and final answer is 23,032.17 centimeters per centimeter. That is option number B is correct for this. Question number 38. Which of the following series of emission spectral lines for hydrogen is observed in ultraviolet region? Here which option is correct for this? Lyman series. You check this box. Here I have given some extra information for you. Then you can check it. Balmer series is spectral region visible. Then Bastian series and bracket series and Fund series, this all are lie in the spectral region of infrared. Then for this question option number A is correct for this. Question number 39. What is the energy of an electron for hydrogen atom in Bohr's first orbit if the energy in third orbit is minus x joules? Here information is given. Energy of electron in third orbit E3 we will consider. E3 is equal to minus x joules. Then for that if we write formula we will get minus 2.18 into 10 raised to minus 18 1 into bracket 1 square upon 3 square. Then if we make some changes in that, then we get minus 2.18 into 10 raised to minus 18 is equal to minus 9x into minus 9x joules. Then for the same, we will use same formula, and here we will use formula for the first orbit. Then we get E1 is equal to minus 2.18 into 10 raised to minus 18. This time both numerator denominator becomes 1 same only. That's why our final answer will minus 2.18 into 10 raised to minus 18 joules is equal to minus 9x joules. Then for the first orbit, what we got the energy? 9 joules. Then option number 1 is correct for this. Question number 40. What is the energy associated with third orbit of the hydrogen atom? Here Rydberg's constant provided. Then by using the formula, energy of the energy associated with the orbit En is equal to minus 2.18 into 10 raised to minus 18 z square upon n square. Here z is equal to, we will put 1 and n is equal to 3. By putting the values, we get the final answer minus 0.24 into 10 raised to 18 joules. And for this, option number C is correct. Question number 41. What is the energy associated with the fourth orbit of hydrogen atom? Then same like the previous question. Here n is equal to 4 we will put. Remaining all things are same. Then by putting the values, we get answer minus 0.136 into 10 raised to minus 18. That is your option number D is correct for this. Question number 42. What is the momentum of a microscopic particles having the de Broglie's wavelength 6.0 Armstrong? Here Planck's constant value provided. Then according to the de Broglie's equation, we have lambda is equal to h upon p. Then we will convert it for the p. P is equal to h upon lambda. By putting the values, we get answer 1.1 into 10 raised to minus 24. That is option number B. Question number 43. What is the amount of energy associated with first orbit of monopositive ion? Here Rydberg constant also provided. Then here is the formula. En is equal to minus 2.18 into 10 raised to minus 18 z square upon n square. Here z value we will put 2 and n value we will put 1. Then after calculation we get minus 8.72 into 10 raised to minus 19. Then which one is the correct option here? Here option number D is correct. Question number 44. What is the wave number of lowest transition in Balmer series? So the lowest energy in the Balmer series is from N1 is equal to 2 and N2 is equal to 3. By putting these values, we get RH into 5 by 36. That option number B is correct for this. Question number 45. Calculate radius of fourth orbit of boron plus iron. Here we have the formula for this. Calculating radius of orbit, Rn is equal to 52.9 into n square upon z. Then here in this formula we will keep z is equal to 5 and n is equal to 4, because radius of fourth orbit is asked, means n is equal to 4. By putting these values we get the answer 169.3. That is your option number A is correct for this. Question number 46. Which of the following rules states that it is impossible to determine simultaneously the exact position and exact momentum of an electron? From these four options, option number C is correct for this Heisenberg's uncertainty principle. Question number 47. What is the wave number of lowest transition associated with Lyman's series? Here value of n is equal to 1 is provided, that is lowest transition associated, that is orbit number 1. इलेक्ट्रॉन कैन ट्रांसमिट, इलेक्ट्रॉन कम से कम कौन से ऑर्बिट में आ सकता है लाइमन सीरीज में? n इज इक्वल टू 1 ऑर्बिट में. तो यहाँ पे अगर दूसरे ऑर्बिट के बारे में नहीं पूछा है तो लोवेस्ट ट्रांजिशन आपको यहाँ पे इंफॉर्मेशन प्रोवाइड किया है। लोवेस्ट ट्रांजिशन मीन्स कम से कम कौन से ऑर्बिट से लोवेस्ट ऑर्बिट में, फर्स्ट ऑर्बिट में इलेक्ट्रॉन आ रहा है, तब आपको वेव नंबर पूछा है। तो यहाँ पे आपको n इज इक्वल टू 2 जो फाइनल ऑर्बिट रहेगा जहाँ से इलेक्ट्रॉन का ट्रांजिशन हो रहा है उसको n इज इक्वल टू 2 लेना है। और फॉर्मूला तो आपको पता है, वेव नंबर इज इक्वल टू रेडबर्ग्स कांस्टेंट इंटू 1 अपॉन n1 square minus 1 upon n2 square. Then by putting the values we got that RH into 3 upon 4 cent per centimeter. That is your option number C is correct for this. Question number 48. Calculate the radius of first orbit of lithium plus 2. यहाँ पे रेडियस का फॉर्मूला आपको पता है 52.9 into n square upon z. Then here z is equal to 3 we will keep and n is equal to 1. After putting the values and calculation we get 17.63 pm. That is option number C is correct answer for this. Question number 49. What is the de Broglie's wavelength for a particle having mass 6.64 into 10 raised to minus 27 kg moving with velocity of 3 into 10 raised to 3 meter per second? Then Planck's constant also provided. Then we know the formula for the wavelength, lambda is equal to h upon mv. By putting the values we get answer, final answer 0.033 nanometer. Here in the options only it is asked, whatever the answer we have to convert it into the nanometers. After conversion we get the option number B is the correct for this. Question number 50. Which of the following series of emission spectrum lines for hydrogen observed in the visible region? Option number D is the correct for this.